Yes, sir.
Okay, good. All right. So today we will try to do as much as we can on chapter 1, and we'll see where are we in chapter 1, so that in the next class we can continue. All right. So my notes have all been uploaded to the UFuture, so you can just get my notes there, and we will follow my notes accordingly. All right. So today we will begin our lecture with chapter 1. All right. And I will show you what are we going to do today. So today we are going to do, if you look at the screen here, 520, okay. So we are going to do chapter 1, okay. So chapter 1 consists of 4 subtopics. What operating system do, operating system operation, resource management, and security and protection. Okay, so this is the first week lecture. Okay, so each lecture will take about sometimes 2 to 3 classes to be completed. Okay, so today we will finish topic 1, and then we move on to topic 2, and so on, so on forth. Okay, so the lectures for this course will take for the first 6 weeks is up to chapter or topic number 6. Okay, and then after topic 6, after your mid-semester break, as I explained to you, you will have your mid-semester break, and after that you will have your first test, which takes in about 30% for 2 hours, which covers topic 1 to topic 6. Okay, so that is our plan for this semester. So the first week, the first 6 weeks is just chapter 1 to chapter 6. Okay, so today, inshallah, we will start with chapter 1. Okay, so as I show you here, we are going to do operating system. What operating system do, operating system operation, resource management, and security and protection. Okay, so this is chapter 1 for today. Okay, can you all see the notes? Okay. All right, so chapter 1 is just a little bit of an introduction about operating system operation, resource management, and protection. Okay, so I've highlighted the topics of interest that you need to cover in this slide or in this topic. Okay, some of the slides in this lecture, there will be a lot of slides, but we are only going to cover the important parts or the basic information that is needed by you to understand operating system. Okay, so the objective of this topic is to describe basic organization of computer system, meaning to say, how does the computer system look like? It's nothing to do about the operating system yet, and the components, and how is this computer system linked to the components of an OS. And we are also going to look at types of computer environment. Okay, what kind of computer system environments you have, because each operating system works differently sometimes for each computer system. Okay, because we have a few types of systems available. There are batch processing system, there are time sharing, there is hybrid, there is real time. So each computer system is different, and each system requires different type of operating system. Okay, different type of operating system. For example, let's say when you go into a shopping mall, a supermarket, at the checkout counter, when the cashier scans item, okay, so that system is also a computer system. That system also has an operating system, but that operating system, although it's sometimes Windows, is different from the home Windows environment. Okay, that is a more, or what we say is a real-time operating system, whereby when you scan the items on the goods, automatically the price appears. Okay, and that kind of computer system only works with that kind of operating system. All right, so those are the things that we are going to cover. And we are also going to cover several open source operating systems. What do you mean by open source? the easiest explanation for open source is it's free, it's available for you to download, and basically you can custom make your operating system according to the features and services that you need. Okay, so this is a explanation of an operating system which you need to understand by the end of this chapter. What is an operating system? Acts as an intermediary between a user, myself, and the computer hardware. Okay, so if you have a PC, personal computer, laptop, and that laptop, there is no operating system, then it's merely of a user and a hardware. So in order for you to access that hardware, you need an operating system to access the particular hardware of interest. Okay, so operating system goals: execute user program, you as the user, make solving user problems easier, make the computer system convenient to use the computer hardware in an efficient manner. Okay, point number 2, make the computer system convenient to use. So what does that mean? I'll give you an example. Let's say you own a car and you want to find out if your car has enough petrol. So what do? You just look at your dashboard and the indicator will show whether you have enough petrol. Okay, that indicator, that dashboard indicator, acts as an intermediary between you and the fuel pump, because the fuel is all stored inside the fuel pump. So there are sensors inside the fuel pump which signal back to the dashboard in order to tell the user, yes, there is enough petrol. If you do not have that, let's say something is wrong with your dashboard, then you have to manually open your fuel pump to see if you have enough petrol or not. But in this case, you have that dashboard system. Okay, so that makes it convenient for the user to see if the car has enough fuel or not. So that is the basic idea of what it means by make the computer system convenient to use. Okay, if you do not have an operating system running on your PC, then how are you supposed to use your hard disk? How are you supposed to use your RAM? Okay, you don't have anything. So the operating system acts as an intermediary, something in between. So these are the structures that you need to understand in a computer system. It's divided into 4 components: hardware, OS, application program, and the user. So the user can be so many elements here. It can be a person, it can be another machine or another computer, because you can connect your PC with another machine. Machine here means you can connect it with your printer, you can connect it with your USB port, web camera, you can connect it with your scanner, you can connect it with so many other things. Okay, so these are considered the users of the computer. All right, and application program is different from operating system, whereby application program is defined the way in which the system resources are used to solve the computing problem of users. So you can have word processors like Microsoft Word, you have compiler, Java compiler, C++ compilers, you have a web browser, database system, you can play video games. So these are all what we say as an application program. So application program basically means a program which has a meaningful output. Okay, it's a program which has meaningful output. Okay, and an application program is not the operating system. However, application program needs the operating system to run the program. Okay, you can have Excel, but if your Windows operating system is not working, then you cannot access Microsoft Excel or PowerPoint or so on and so forth. Okay, so application program is actually what we say is a type of program, a specific type of program to solve specific problems as well. All right. Next, we go on to operating system. You can control and coordinate the use of hardware. So now you want to coordinate which hardware goes to which application and which users. Okay. For example, let's say you are scanning a document. So scanner is a type of user. So you have the operating system will determine which application is linked with this scanner. Okay, so scanner is the user, application is the scan program. So which application is automatically is related to this particular user. So the operating system will coordinate. Okay, this scanner is related to this application program. Next, we also have the hardware inside the computer system. So you have the CPU inside, you have the memory, input output devices, you have the motherboard. So all of these are all the hardwares which are located inside the computer system. Okay, so this is how basically the four components are all linked. All right. So you have the users here. Users mean machine, it means a computer, it means a normal user. Okay, so these are all connected to each, and so each user can use different types of application program. So what is the difference now? You see there's a word called system program. So what is the difference between application program and system program? Well, application program are programs that have specific output. Microsoft, PowerPoint, these are all application programs. They have specific output. But if you are dealing with system program, now system program is different from application web program, whereby system program is like your antivirus. Okay, it's like your sorry. Okay, it's like your antivirus program. It's like your Microsoft Windows, your Windows system, your scan disk. Okay, so these are application system programs because these programs are linked with the operating system. And next, this application and system program are all needs to have operating system which is connected to the hardware. Okay, can you give me 1 minute? Just I need to answer something. Can you just give me 1 minute? Bagi saya 1 minit, boleh tak? So we just
Boleh,
stop
boleh.
for,
Yes,
we start back at 9:20 7 minit je tu 9:20 we stop back. Sekejap. All right, now we get back to our class. So sorry, I had to do something just now. Okay, can you see this?
Yes.
Yes, sir.
Uh, okay, all right. So what does an operating system do? Depends on point of view. User wants convenience. So operating system provides ease of use. It provides resource utilization. That means ease of use means makes it easier for the user to access each hardware and software in the personal computer. So that is the meaning of ease of use. User, when you say user here, it does not mean a person like me. It means a person like me, but it also means another system, another machine, another computer, because all of them, if they are linked to the personal computer, it also means it's a user. So it means ease of use. That means it provides easiness, or it makes things simple for a user to access the operating system. To access the computer hardware in the personal computer. And it also provides resource utilization. What is resource? That means resource means like your processor, your hard disk. So you are easily able to utilize it more efficiently. Okay, so each user to the system can utilize the hardware in a easier form of manner. Okay. But shared computers such as mainframe or microcomputer, mini computer, must keep all users happy. Okay. So what is a mainframe? A mainframe is actually a large big server which has higher process capability, and same as the main mini computer, although it's mini, but it's actually it has more functions, and it needs to keep each user happy. Okay, each machine needs to be connected to the server and should have enough resource utilization. Okay. Users of dedicated systems such as workstations have dedicated resources, but frequently use shared resources from server. Okay, workstation, it means like if you go when you go to the bank, the cashier in front of the system, so that is a workstation. It only has a monitor and a keyboard, but the CPU is all connected to the server. So each user, each teller has a dedicated resources in the server. I mean, it has a dedicated space in the server. So whatever transaction is being done, it directly goes to the server. Okay, so the server is actually sharing that same PC with a few more other tellers. You can just imagine you have one CPU, but it's shared by a few users. That means each user has only a monitor, keyboard, monitor, keyboard, monitor, keyboard. So you have 5 people sharing one particular CPU. So that is something what we call as a workstation. A handheld computer are resource poor, optimized for usability and battery life. Handheld computers are basically like your phone. These are handheld. Okay. A resource is poor, yes, because you cannot have multiple users connected to the system. You can have only single user. Okay, so your phone is only a single user, so the resource is very limited. That's why it says poor, but it's optimized for usability. You can keep using it for a long period of time, and it focuses on optimization of usability and battery life. So this is the focus of it. Okay, the focus of a handheld system. Yes, resource poor because they don't have much resources. They don't have much space. Okay, like your phone, it only has a certain limit of hard disk space. It only has a certain limit of a RAM size, but it is optimized for usability and battery life. Okay, some computers have little or no user interface, such as embedded computer in devices and automobile, such as What do you mean embedded? Embedded means, for example, you have your inside your car you have the dashboard system there. Dashboard tu ada petrol consumption, ada bila nak service. So those are all actually a computer system, but it doesn't have a proper interface. It's only connected straight into the hardware of the, or it's only connected straight to the engine of the car, automobile. Okay, so these are examples of embedded system, embedded computer devices. Okay, your ATM machine, these are all embedded. Okay, embedded means is also running in only one program. ATM machine je lah. You cannot do anything else. Okay, the teller system, your photostat machine, these are all embedded. Okay, a mainframe is a big, these are big PCs over here. Okay, and then workstation, okay, these are all monitors and keyboard, but it's all connected to one big server here. All right. This is also another embedded computer system. This is inside the car. So your brake system, everything is all connected inside. Okay. And this is a mini computer. Normally you will see it in banks. This is also connected to the mainframe, but it's only, it's very small. It only can do certain processes. Okay. And this is the handheld system, a handheld device. Yes, a poor resource. It's like your phone as well. Okay. It can only do certain processes only. Okay, next, OS is a resource OS is a resource allocator. Okay, what is resource allocator? Resource allocator is something like this. Let's say we have a few people, few humans connected to the CPU. Now, the CPU has only this much size of hard disk. Let's say the size of a hard disk, let's say, is about 100 gigabyte. So each user, the OS will allocate certain number of space to each of the resources. Okay, you ambil dua, you ambil dua, you ambil dua, you ambil dua, something like that. Okay, so if I were to draw, can I draw? Yes, I can draw. So this is your computer. Assume lah, walaupun tak cantik, bila komputer awak. Okay, so inside this computer is your hard disk. Hard disk. Okay, assuming you have a few people connected to the system. You have the user number 1, user number 2, user number 3, and user number 4. Okay, and this hard disk space, let's say, is 100 gigabyte. GB. Assume lah, cantik lah tulisan saya. Okay, so each user will get 20 or 25 gigabyte. So who gives this space? Who allocates this space? So the OS will allocate accordingly. Okay, you dapat berapa, you dapat berapa, you dapat berapa, do you? Decides between conflicting requests for efficient and fair resource use. What does it mean? Because this computer is also linked to a printer. Okay, so let's say user 1 nak print and user 2 pun nak print. So OS will allocate, okay, jangan conflict, there shouldn't be any conflict. So OS will manage, okay, user 1 print dulu, habis, then user 2 jalan pula. And then user 3, and then user 4, macam tu. Okay, and so that's why we say OS is also a control program. It controls which user, which program runs first, which program utilizes first, which program utilizes second, and so forth, and so on and so forth. So these are the main, these two is what we say the main definition of the operating system. So the question comes out and say, define an operating system. So you can also define the main points of an operating system. So you can say, yes, OS is a resource allocator, and OS is also a control program. Okay. So there is no actual definition, or to be exact, the one definition which can fit all of the operating system. However, I like the definition of point number 3, the one program running at all times on the computer. Okay, it runs all the time. When you're on your PC, the operating system runs. Okay, but there is a word called kernel. What is a kernel? Okay, so let me give you an example of it. In order for you to run the Microsoft Word or PowerPoint and so on and so forth, you need the operating system. Betul, you need an operating system. You need Windows. Kalau you tak ada Windows, macam mana you nak run PowerPoint and so on and so forth. But in order for you to run the OS pula, you need something. So kernel is something which is embedded inside the operating system. So the kernel, which actually you can say is an operating system inside the operating system. So kernel is actually the brain of the operating system. So the kernel will also decide how the operating system functions. Okay, we'll come to the kernel explanation in detail later. Next, we also look at the computer startup. That means this is we are talking about how the PC boots up from zero to what you see now. So there is a program called the bootstrap program. The bootstrap program is only loaded when the PC is on. The on process. Okay, the on process. Yeah. So when you're on, like for example, when you want to start the car, you put in the key, you put the key into ignition, and then when you start the car, what happens behind it? The petrol goes in, the spark plug goes in, and everything, and the combustion happens, and then the car will start. So same as the operating system, computer system. It is known, the program that is initialized in the beginning is what we say as the bootstrap program. And this bootstrap program is stored, dia akan simpan dalam your ROM. ROM, as you know, is you cannot delete it. Okay, it's permanently inside the system. Okay, it's known as the firmware lah. Okay, so you cannot just go and buy a new ROM. If your ROM rosak, there is no thing that okay, I set up the ROM 2, tak ada. It does not work that way. Okay, the bootstrap program is always inside the computer system, even if you change the operating system. Let's say I'm now running in Windows 10. Tomorrow I tak suka Windows 10. I format my PC and I run Linux. So the bootstrap program also works in Linux. So the same bootstrap program works for any type of computer system. And you have the same bootstrap program inside your iOS as well. And you have the same type of function of bootstrap program inside your phone as well. Namun juga if you restart your phone, okay, the same thing appears as well, but on a different condition lah. All right. Okay, so this is the computer system organization. How is the hardwares connected to the CPU and the computer system and the memory? One or more CPUs device controllers connect through the common bus providing access to the shared memory. What is a shared memory? Shared memory is your RAM lah kat sini. Okay, so this CPU, dalam CPU ni is your processor. Each hardware has a controller. This one controller ni. In order for you to have one hardware, you have a controller. So this is your hard disk. It has a disk controller. This mouse, keyboard, printer has a USB controller, and for your monitor, you have a graphics adapter or graphic card lah. Okay, so it's the same. So that's why if you want to change your monitor to your higher end, you need to increase this graphic card adapter. Okay, sekarang ni saya pakai monitor what is this? 15 inch monitor. Let's say saya nak connect my PC with the TV. Boleh, tak ada masalah. I have a HDMI cable, I can directly connect. But if my graphic card or my graphic adapter is not a high end, that means the graphic card has to work more because now it has to because in a 15-inch PC banyak ni je color yang diperlukan, banyak ni je pixel yang diperlukan. So if you put it in your TV, lagi besar. So lagi besar cahaya dia, lagi besar color dia. So you need a more high-end graphic adapter. So bila you perlukan more high-end graphic adapter, maka you need a better graphic adapter so that more color can be displayed on your monitor or your TV. Okay, so each of these hardwares or controllers are connected through bus. Bus is something like a wire, you can say, which is controlled. So the data from, let's say you type something here in the keyboard, data will be going here, will be kept inside your memory and also be processed inside your CPU. Once the processing is done, the data will travel back and go inside your USB monitor controller or your graphics adapter and display in your screen. So these are all connected through something which is called a common bus, okay, and has access to the memory. So this memory is all connected to each of these controllers. Okay. So now in the latest functions, the graphic adapter also has a memory space inside here. Why do you have that? Okay, because if you play, let's say you are playing YouTube or you're playing a movie, okay, so the movie is actually kept inside this memory location here. So all the movies which comes out displays here is actually inside here, coming from here. So let's say your memory space is katakan senang 30 megabyte. So 10 daripada itu, 10 megabyte dah rugi because you nak simpan gambar untuk monitor. Kena access only 20. That's why now you have additional or you have graphics memory inside here so that yang 10 tu sekarang disimpan di sini. So dia tak pakai location kat sini dah. So this 30 megabyte can be utilized for other programs as well. Okay? Are you with me? Faham tak? Any questions so far?
Faham, sir.
No, sir.
Okay, are you sure? Hello, hello? Semua okay di sana?
Okay, sir.
Okay,
Yes,
sir.
sir.
Okay, sir.
Okay, sir. Okay. Dah makan dah? Have you all had your breakfast?
Yes.
Belum.
Belum.
Sudah.
Belum lagi. Sir.
Ah,
Belum, sir.
Belum, sir. Dah, sir.
Sudah.
Belum makan.
Sudah, sir.
Alhamdulillah. Siapa yang sudah ni? Alhamdulillah. Bagus. Rashidin dah makan dah? Tak. Saya pick nama je. Mesti dia tak ada kat situ. Assalamualaikum Rashidin. Apa khabar? Jika anda berada di sana, typelah message dalam chat box. Oh, tak ada. Rashidin tengah makan kat situ. Dan tahu dia tengah tidur. Rashidin, awak tengah tidur ke? Halo, halo. Halo, halo. Halo, halo. It's okay. Nanti Rashidin akan message saya, dia akan cakap, mic saya rosak. Saya nak cakap sir, tapi mic saya rosak. Biasalah alasan dia. Okay, where were we? Sekarang ni kita ke mana? Operation. Okay, here we are. All right. Input-output devices and the CPU can execute concurrently. What is an input-output device? Keyboard, monitor, mouse, input-output. Okay, it can either do an input or it can do an output. Okay, so the input and output and the CPU can execute concurrently. That means it can happen at the same time. Okay, it can happen at the same time concurrently. Meaning you can, macam saya ni, this is an output, monitor is an output. Okay, at the same time I can do something else in the CPU. Okay, it can act concurrently. Each device controller is in charge of a particular device. Each controller ditugaskan untuk jaga hardware yang ni. Controller ni jaga dia ni. Controller ni jaga dia ni. Okay. CPU moves data from and to main memory from local buffers. Okay. So kerja CPU, that's the diagram tadi. The CPU's job is to move data from the buffer is inside here to the memory. Because let's say you are scanning something here. So the scan document comes through, let's say this is a scanner, comes through and is kept inside a buffer here. So from the buffer to the memory, you need the CPU job to actually bring the data from here masuk ke dalam memory. That is the device controller, the CPU punya kerja. The input output from the device to the local buffer of the controller pula. I/O is the I/O from the device to local buffer of the controller. So the CPU also, the CPU gets data from the controller ke dalam memory, and the CPU also brings the memory data yang dah diproses ke dalam your buffer balik. Okay, macam tu lah dia. Alright, so the CPU's job is to get the data from the local buffer of that particular hardware, bawa masuk ke dalam memory. Because you see, you have to understand, the computer system does not know what to do. Okay, apa yang kena buat? Contohnya dekat pasar raya, bila dia scan item tu, dia scan item dekat barang tu. So the computer system needs to be told, apa nak buat ni? So what to do? Dia dah scan, data tu dah ada, so data is kept inside the USB controller or driver here. Okay, now what to do with the data? So CPU will take that data, bawa ke dalam memory to be processed. Okay, CPU pun akan proses. Okay, dah dapat display dia. Oh, ni harga dia. Okay, now what to do? Displaykan dekat grafik. So CPU akan bawa data itu ke dalam graphic adapter untuk di display. Itu. Because you have to understand the computer system does not know what to do until the user tells it what to do. So bringing the data to be processed from the buffer dalam device ni ialah tugas CPU. So the CPU will do two things. Actually, it's doing two things. One is to bring the data from the device into the memory. Yang kedua, process that particular data. Okay? Process that particular data. Okay? Because each time you open Microsoft Word, your Word document is in two places. One is inside the RAM. Dia duduk dalam tu. Because the RAM is always the current file. And the data is also, the file is also inside the processor. Dia tengah diproses kat situ lah. So each time you press save kat situ, proses di dalam CPU tu dia akan save, update memory and update your hard disk as well. So the processor's job is actually to coordinate, okay, what to do. Okay, ini save kat sini, masuk kat sini. Okay, so the operating system will itu tugas hardware pula. So operating system will coordinate this. Okay. Device controller informs CPU that it has finished operation by causing an interrupt. Okay, if the device controller dah save, let's say you dah save data into your hard disk, so there will be information, so they will set interrupt to the CPU. Some interrupt kita boleh nampak lah, ada interrupt yang kita tak tahu. Contohnya kalau macam interrupt yang kita boleh nampak, normally printer lah. Bila printer habis ink, dia akan interrupt, dia akan signal to CPU, habis ink lah. So CPU akan fikir, okay, sekarang aku dah dapat, I've got an interrupt from the printer saying that it has finished ink. So what should I do next? So CPU akan check dalam proses dia apa yang perlu buat. I have to tell the user. Dia hantar data itu melalui memory to the graphic adapter. Dia akan keluar kat monitor you, printer finish ink. So that's how you know. Habis ink. So you pergi tak ink. Press OK. Bila you tekan OK, data pula akan masuk balik dalam CPU and memory. CPU will say, dah habis dah ada masuk ink baru dah. Okay, now resume balik printing. Macam tu. So that resume balik printing tu, in that information tu akan masuk dalam bus and straight to the device USB controller and signal the printer, okay, you boleh teruskan print. So this is how the system works. Okay, so this is how lebih kurang lah everything is connected. I think we showed you the previous diagram. Okay. So what is an interrupt pula? Interrupt are signals sent to the CPU by external devices, normally input-output devices. So it's a signal lah, dia akan hantar satu signal. Some signals we can see, some signals we can't see. Like the printer we can see, some signals we can't see. Okay, it's between the input-output and the CPU. Dia akan hantar satu signal, kata dah siap. Okay, it's a signal, internal signal. Okay, so dia ada hardware interrupt, dia ada software interrupt, dia ada traps. A hardware interrupt is whereby contohnya macam keyboard, this is a hardware. Bila saya tekan P, the CPU will get it as an interrupt and okay, what to do with this? So dia akan keluarkan the letter P dalam graphics, dalam your monitor. So this is what we say is a hardware interrupt. A software interrupt is bila you contohnya you are programming, tiba-tiba you dapat error dalam programming tu. That is a software interrupt. Okay. So, biasanya lah, ini student selalu buat, selalu kena, you dapat blue screen tu. A blue screen is also considered as a software interrupt. Okay, software interrupt. Okay. Why is interrupt important? Interrupts are important because they give the user better control over the computer. Without interrupt, a user may have to wait for a given application to have a higher priority over. Ini apa maksudnya? Why is interrupt important? So when you read the statement here, user, it does not mean awak tau. It means other machines semua. Because each time information is sent by other machine ke other devices, it needs to know information itu dah sampai ke dekat CPU. Okay, information itu dah sampai ke dekat CPU. So that's why there is an interrupt. Or you need to tell the computer system what to do with this data. So they will send you an interrupt. Okay, contohnya, as simple as you type dekat keyboard alphabets, but the CPU doesn't know that what to do with this type of information. So that's why it's called an interrupt. The interrupt tells the CPU, okay, this is a hardware interrupt, but it is nothing wrong. Keluarkan information yang saya type ni ke dalam monitor. The interrupt is actually telling the CPU what to do next. Printer bila habis ink, dia keluarkan satu interrupt. It's telling the CPU, okay, I have finished my ink. Please tell the user, keluarkan message ni kepada user. Kepada Imran, keluarkan satu message kata ink habis. So the CPU will keluarkan message. Because you have to remember, CPU ni dia tak tahu satu benda pun, dia tak tahu apa nak buat sehingga you cakap dengan dia apa yang nak buat. Okay. So, and you have to tell, the interrupt tells the CPU what to do and where to display the interrupt. Ink habis. Printer interrupts the CPU saying that ink habis. Okay. Dalam artikel lain, the CPU will ask, okay, ink habis. Oh, aku nak buat apa? So the interrupt says, the signal says, okay, tolong cakap dengan Imran yang printer ink habis. So there was a message on the screen. Okay, there is an interrupt. Alright, something like when you install a software. Bila you install a software, you install. Bila dah habis install kan, you get a message dah habis install. So that is a software interrupt because you are doing the software. So when you get the interrupt, you know, oh, okay, dah habis install. So now I can open the program or I can run the particular program. Kalau you tak tahu, sampai bila you nak tahu? Okay, so a software interrupt pula is an interrupt from a software. It's not from a hardware. Why is it important? Because it needs to tell the user that the process is completed or the process is corrupted. Contohnya, you want to install a software on your phone, an app on your phone. Tetapi your app, you don't have enough space. So there's a software interrupt telling you, oh, not enough space. But if you don't have that software interrupt, then how do you know? Nak install tapi tak boleh, nak install tapi tak boleh. Kenapa? Tak tahu. There is no message kat situ. Okay, so this is why interrupt is very, very important. So common types of interrupt, okay, ada interrupt vector, ada interrupt driven. Interrupt vector ni controls the address, dia ada address lah. meaning what to do next. Dia ada bagi address semua lah. Okay, so these are some things we will cover that in next chapter, belum hari ni lagi. Let me see what else do we need to cover. Resource management. Alright. Okay, interrupt vector. Right. So interrupt vector, and there's also interrupt driven. There are two types of interrupt. Okay. Kalau it's a software, we call it as a trap or exception. That is also a type of interrupt. So interrupt vector contains the address of all services and routine. What does it mean? Okay. So let I explain to you. When the hardware has a problem, contohnya printer habis ink. So the printer will signal back to the CPU kata habis ink. So that is called a hardware interrupt. Tetapi dalam printer tu it will be called as interrupt vector. That means dia beritahu CPU, okay CPU sekarang saya dah habis ink. Please execute address number 4. Kenapa dia cakap itu? Because dalam address number 4, where is address number 4? Address number 4 mungkin dalam hard disk. So the address number 4 ini contains apa nak dibuat jika habis ink. Because the CPU does not know what to do next. So the hardware comes up with the interrupt vector to tell the CPU, I have finished ink and please execute address number 4, which is inside the hard disk. Okay, it's like this. Let's say we are in a face-to-face environment in class and we are having our test. Suddenly one of you do not understand question number 5. So you interrupt, you angkat tangan, you interrupt me. If you do not tell me you have a problem in question number 5, I do not know what to do. Saya cuma tahu there's an interrupt by you. So I come to you. Apa nak buat? So you tell me question number 5. Oh, then I know, oh, you have a problem in question number 5. So that is what it means by interrupt vector. So I am the CPU, you are the user, so you interrupt me by telling me question number 5. Angkat tangan, question number 5. That means you have a problem in question number 5. But if you do not tell me you have a problem in question number 5, you just interrupt me. So, okay, I come to you and then habis kat situ lah, you do not know. Okay, so interrupt vector is important because it tells the user, it tells the CPU what to do next. Okay, next is also interrupt driven. What is mean by interrupt driven? Interrupt driven is also something which happens through another process. Okay, interrupt driven ni pula. That means operating system will also handle interrupt driven. That means in order for something to happen, each process is interrupted is based on interrupt driven. That means contohnya macam tadi tu, interrupt vector, you angkat tangan, you cakap question number 5. So I know what to do. So I know, okay, lepas ni I need to answer you in question number 5. Okay, so each of the process which is happening inside the CPU is interrupt driven. That means proses cakap dengan CPU. Oh, dia ada interrupt, baru is driven, baru it happens. Each process that is going on inside the CPU is interrupt driven. That means asalnya daripada satu interrupt. So in the class where the exam is taking place, if nobody interrupts me, then there's nothing. Tak ada apa-apa. Okay? But a process happens bila ada satu interrupt. Or another example is whereby macam scanner tu. Scanner dekat shopping mall tu, dekat supermarket tu. selagi mana that lady does not scan on the barcode, the process is not happening. The scan interrupt happens, then only the process takes place. Then only barang akan display dekat di cashier tu lah. Okay. So the interrupt also determines what to do next, and interrupt also what pooling. That means kalau ada beberapa interrupt masuk, which interrupt goes first? Interrupt mana yang paling penting? So this is what is called as pooling. Okay. So ada juga interrupt dalam bentuk vector yang macam saya kata tadi, vector. So you have which vector comes first? Adakah vector ni lagi penting ke vector ni lagi penting? So this is also handled by the CPU juga, the operating system as well. Okay. So this you can read on your own. What is the difference between interrupt and pooling? Okay. Okay. Next. Okay. I think we can. This one also boleh lah. Ini sama je. You can read on your own. Okay. I think we stop here. This I think you dah pening dah kat situ. Because normally I will stop here for lecture 1. I did not want to go too much on theory on the first day of class. We stop here at direct memory access, and we will continue next week in the same chapter 1 juga, so that you are able to understand a bit more on chapter 1. Okay, so we will stop at slide number 22, direct memory access. So inshallah on the next class kita akan continue direct memory access. Okay, alright. So do you have any questions for today?
No, sir.
Alright. So
No,
what
sir.
we have done, okay, so we have completed already, okay, so we are now almost dalam sini, OS operations, we are now here already. So by the end of next week, next class, inshallah, we are able to complete our chapter 1. Okay, so next class we will start with direct memory access. Okay, all right. Okay, thank you so much for today. Inshallah, I will see you in the next class. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.